In this worksheet, we are going to learn how to draw double and triple covalent bonds. So far, you have learned how to draw covalent bonds, and even though we didn't say it, they were actually single covalent bonds, which means that you have two atoms that are sharing a pair of electrons. One electron comes from one of the atoms, and the other comes from the other. And they're doing that so that they can each have a total of 8 electrons around them. But what we're going to find on this worksheet is that sometimes just forming that one shared pair of electrons, that one single covalent bond, is not enough to get 8 electrons around each of the atoms. And so in that case, the atoms sometimes have to resort to a double bond, two shared pairs of electrons, or sometimes even a triple bond, which would be 3 shared pairs of electrons. But the one thing that is really important to remember here is that atoms always prefer, if possible, to just be involved in single bonds, right? One thing that's in bold here is that double bonds are much stronger than single bond, and in the same way, actually further down the worksheet, it's going to tell you that triple bonds are even stronger than double bonds, right? And so it would seem like, oh, maybe stronger is better. But what that really means for the atom is it gets held much closer to the other atom that it's sharing with. And atoms do not like to be really close to each other. That's a high energy state, and so they try to avoid that. So that's a really long way of saying that when you go about drawing a covalent bond, you want to start off assuming that it's going to be all single bonds. That's way more common than a double or a triple bond. And if you go into something just assuming like, oh, hey, this looks like it's going to be a double bond, or I bet this is going to be a triple bond, that can get you into some trouble quickly. So even though this worksheet is titled double and triple bonds, so we know that it's all going to end up being double and triple bonds, I'm going to go about it assuming from the beginning that it might be a single bond and kind of let myself discover that it's going to be a double or a triple bond. Because eventually when you start getting worksheets with a whole mix of single and double and triple bonds, you're going to need to be able to figure out when each is appropriate. So if that didn't all make sense, then hopefully an example will help to clarify. So we're going to start off with the example of carbon dioxide. And we do start the same way that we did the single bonds on the previous worksheet. So we're going to count up, first of all, the total number of electrons we have. Because carbon is in the fourth row, it has 4 valence electrons, and oxygen, excuse me, by row I mean column, and oxygen is in the 6th column, and so it is going to have 6 electrons, and because there's 2 oxygens, each of them contributes 6, and so that if we add it all up gives us a total of 16 electrons. So we need to make sure that our final answer has no more and no less than 16 electrons in it. And we are still going to, as our second step, just like in the previous worksheet, identify our central atom, which in this case would be carbon because there's only one of them. And I'm just going to connect the carbon and the oxygens like I would have, assuming single bonds. And so that used up 4 total electrons. And now, just like in the previous worksheet, I want to start putting extra electrons around my outside atoms before my central atom. So I've already used 4, 6, 8, 10, 12, 14, 16. So I've used all of the electrons that I had to start with, all 16, and I have successfully gotten 8 total electrons around each of my oxygens, but my carbon right now only has a total of 4 electrons around it. And that doesn't satisfy carbon, which wants to have 8 around it, but I can't simply draw in more electrons because I've already used my 16. And so I'm going to see if I can make a double bond. So what that means is that I'm going to pick one of the pairs of electrons that are not currently being shared, so the ones that are being represented as individual dots, and they're going to actually just move. They're going to kind of relocate into a shared space between the carbon and the oxygen. So it really doesn't matter which of the unshared electrons I choose. I'm just randomly going to select this pair here. Okay, and so what's actually going to happen is that these 2 electrons kind of migrate and they move over here. And now they're actually being shared between the carbon and the oxygen, and so we're going to just make a line to connect them. And what's important is that means that they're no longer, my eraser, there no longer are electrons right here because they've moved, right? So you got to make sure and erase them, otherwise you'd end up with 18 electrons in your picture, which would be wrong. Okay, and so in doing that, it's important to note that this oxygen right here has not lost any electrons. It still has 8 electrons around it. It's just that more of its electrons are now being shared with carbon. Okay, and then I'm going to erase that at the risk of getting too many arrows on this picture. The other thing, where did my eraser go? I no longer have an eraser. Okay, well, that's not getting erased then. Sorry, guys. So the other thing is that this carbon now has more electrons around it. In fact, it has 6, but that's still not quite enough because carbon still wants to have 8 around it. Okay, oh, I found my eraser. Good. Okay. Oh, it doesn't work. Man, I'm having eraser difficulties here. Sorry, folks. Okay. So what I'm going to do now, since this carbon only has 6 around it, is I'm going to go over to the other oxygen, and it wouldn't matter which pair of unshared electrons I choose, so I'll just choose this pair here, and I'm going to actually physically move them, and so now they're going to sit over here in between the carbon and the oxygen, and so to represent that they're sharing them, we make a line, right, which means... Oh, good thing my eraser started working. Which means that they're no longer there. So I really have to make sure to erase them. Oh, my eraser won't work on that. Okay, I'm going to cross them off then. They're not there anymore. Because otherwise I'd have 18 total electrons in there. Okay, so now if I look, I realize that my original oxygen right here that was sharing still has 8 around it. And this carbon now, when I look, actually does have a total of 8 electrons around it. So I've satisfied the 2 rules. I've used all 16 electrons, and I've gotten a total of 8 electrons around each of my atoms. And so this can actually be written as my final answer. And you'll see that there's 2 double bonds here. Now, that doesn't have to be the case. Sometimes it'll work to just have 1 double bond, right? But you got to kind of try it on a case-by-case basis. All right, so there's going to be a couple double bond pictures for you to practice with when you get into class, but we should do an example of a triple bond. I'm going to point out the reason that in this drawing here I kind of gave you the setup is because just looking at the formula, it wouldn't really be obvious what your central atoms are because there's not one of carbon or one of hydrogen. So this here, it's not a finished picture, it's just setting up the basic structure for you on one where you couldn't determine the central atom. Okay, so now, if we go down to an example that's going to be a triple bond, I'm going to follow basically the same pattern. I'm going to add up how many valence electrons I have, and nitrogen is in the 5th column on the periodic table, and there's 2 nitrogens, right? So I have a total of 10 electrons to work with in this picture. There's no central atom, but since there's just 2 nitrogens, I know just to connect them. And again, I'm just going to go into this trying to make a single bond work. I'm not going to automatically draw in a double or a triple bond, because later on that's going to get you in some trouble. So that means that I've used 2 of my 10 electrons just in connecting these. So now I'm going to just try to evenly distribute what I have left. So I put there, that's a total of 4, 6, 8, and 10 electrons. And I've now used all 10 of my electrons, so I can't put any more on, but my problem is that none of my atoms, neither of the nitrogens, have 8 electrons around them. They both have 6, which means that I'm going to have to try to make a double bond. So it doesn't matter which of the unpaired electrons, any of those 2 dots I pick, so I'll just, let's say, pick this one, and I'm going to actually relocate them over here, which means it's really important that I make sure to erase them because they're actually not there anymore. They've moved, and now they're being shared between the 2 nitrogens. And when I look, that means that this nitrogen still had just as many as before, right? Sharing doesn't take away from it. It has 6. And this nitrogen's actually pretty happy. It's sitting pretty with 8 electrons around it. But now, this guy over here is like, hey, I shared with you, why don't you share with me? Because it only has 6, and so we're going to have to take another pair of electrons. And again, it doesn't matter if I were to choose this pair or the pair down on the bottom. Either would be fine. So I'll just move this one over here, and now they're going to be a shared pair of electrons instead of sitting by themselves. And so I will go ahead and erase that. And now if I look, both of my nitrogens have a total of 8 electrons around them. I have used all 10 electrons that I was provided, and so I'm ready to write out my final answer in the box over here. So I'll put that there. And then there's going to be one more for you to practice on this front page and a few more on the back. And this is definitely a skill that takes some practice. But again, start off assuming a single bond. Don't forget to count how many electrons you have. Use all those electrons and try to get 8 total around both of the atoms. Your goals from the single bonding previous worksheet have not changed.